Hello everyone. In our last video, we had discussed about the TXY diagram and PXY diagram, and today I'm going to talk about the effect of pressure and temperature on TXY and PXY diagram respectively. The knowledge of these two diagrams are very important when we are dealing with the binary mixture and we are trying to separate these mixtures into two-phase vapor and liquid. And these diagrams help us to restrict ourselves, or it gives us the idea about that, okay, that the maximum range of our temperature and pressure कि कितना मैक्सिमम आप टेम्परेचर एंड प्रेशर को राइज कर सकते हो जहां तक आपको ऑप्टिमम रिजल्ट मिले. Right, if you are increase the temperature so much or increase the pressure so much, then of course you will not get the optimum result from your system. So it helps us to fix our temperature and pressure, because जैसे ही temperature and pressure बहुत ज़्यादा increase करते हो आप किसी भी system के लिए, so separation becomes more difficult. So let's discuss this diagram. So here you can see we have a TXY diagram. On y-axis we have temperature and on x-axis we have mole fractions. So let's take this point as K and this is H and this is T1 saturated S and T2 saturated. So we know that when we increase the pressure of particles, its boiling point is increases. So this is a TXY diagram at a given pressure PA. Here you can see this is the pressure PA which is given to us, and K corresponds T1 saturated of component 1 and H corresponds to saturated temperature of component 2. So what would happens? So when we increase the pressure, boiling point also increases. However, some point of time the temperature will be so high that it will not reach the one of the end of the diagram. So you can see over here, उसने पहले ही just because of temperature आपने rise किया और boiling point उसका rise हो गया, तो ये इसको touch ही नहीं कर रहा. There is so much gap between these two और उसने critical temperature को पहले ही achieve कर लिया. Okay, so what happens here? When you increase the pressure, the mixture may attains the critical point and then you may not be distinguish between the liquid and vapor, or you may not be extend this to here, right? You are not able to be extend this to here. Shrink हो गया your diagram from here to here. आप देख सकते हो जैसे ही आपने increase किया pressure, आपका diagram क्या होता जा रहा है? Shrink होता जा रहा है. Okay, so as you further increase the pressure, then the critical temperature of both, see over here, both the components are attained, and you may not in the position to attain the, see अब आप क्या नहीं attain कर पा रहे हो. Now you cannot reach to both sided. अब आप इसको यहाँ भी touch नहीं कर पा रहे हो on this axis as well as here also. So both जो भी component है, component 1 and component 2, आपने further increase किया pressure तो critical temperature आपको जल्दी attain हो गया. So and you will get only here, you can see over here, you will get only partially two phases. One more effect of pressure on TXY is it not only the diagram move upward. You can see over here it not only move diagram move upward, it also shrinks and the vapor liquid separation becomes difficult and difficult. The other way to see the diagram, if we decrease the pressure, right, if we decrease the pressure, then the separation becomes easy. ओके, आप जैसे जैसे डिक्रीज करते जाओगे प्रेशर, सी ओवर हियर यहाँ पर आपको जो भी फेजेस मिल रहे हैं, दीज आर द पार्शियली फेजेस, राइट. एंड फर्दर अब इफ यू इंक्रीज अगेन वो श्रिंक होता जाएगा एंड सेपरेशन बिकम्स वेरी डिफिकल्ट. ओके, आप एक टाइम के बाद यू आर नॉट एबल टू डिस्टिंग्विश बिटवीन द टू फेज. यहाँ पर ये फेज बता रहे हैं, दीज टू डायग्राम वी हैव ऑलरेडी डिस्कस. क्या शो करते हैं? ये आपके फेजेस को डिफाइन करते हैं. सो जब आप ऊपर जा रहे हो अपवर्ड डायरेक्शन में, ऑफ कोर्स द सेपरेशन डिफिकल्ट होता जा रहा है, आपका डायग्राम श्रिंक होता जा रहा है. एंड व्हेन यू मूव डाउनवर्ड, राइट, so you can see over here the separation becomes easy, right? So the three impact of pressure on TXY diagram. First is it moves upward, and second is if you increase the pressure, the separation becomes difficult. If the pressure is high, then the critical temperature of, you can see over here, the critical temperature of one of the component is attained, and you will not get the full curve. And if further, if you increase pressure very high, then the critical temperature of both the component are attained, and you won't be able to reach the both the axis at x is equals to 0 and x is equals to 1. And similar effects will observe for when we increase the temperature on PXY diagram. So basically this help us to make separation easy. So here you can see this is the PXY diagram with three temperature. So when you increase the temperature on PXY diagram, you will get the same similar effects of temperature on PXY diagram. So I've already told you this help us to make separation easy. Hope you will be able to understand these two diagrams. Thank you.